In this video, we're going to do a few more examples solving quadratic equations in a variety of ways. So all the ones that we skipped during the first video. So remember, a quadratic equation is an equation that can be written ax squared plus bx plus c equals to 0, where your a is not 0, so this is often referred to as your leading coefficient, because it's the highest power, it's the coefficient in front of the highest power of x. Okay, so if you want to solve an equation of that form, one thing you can do is factor it. So if you set it equal to 0, then you can factor it. So we're going to do that for example 2 here. So the first thing I'm going to do is move the 10 to the side with the x's so that I have a 0 on the right hand side. Okay, so that's going to give me 2x squared plus x minus 10 equals to 0. Okay, and now we can use the factoring that we did in the chapter R on this, the left hand side. Okay, so I want two numbers that multiply to give me 2 times negative 10, so negative 20, but add to give me 1, the middle term. Okay, so that's going to be positive 5 and negative 4. Okay, so then we split up the middle term into those two. So I could have plus 5x minus 4x minus 10. Okay, so just to highlight that, so this one term turned into these two terms. Okay, and then we do factor by grouping. So I group these two, I group these two. Remember that it doesn't matter if you switch the order that you write those two, it doesn't make a difference. Okay, so here in the first two I can take out x, and then I'm left with 2x plus 5. In the second two I can take out a minus 2, and then I'm left with 2x plus 5. And now I see that I have 2x plus 5 in both terms, so I can factor that out. And then in the first term I have this x, and in the second term I have the minus 2, so I'm left with x minus 2. And now we have the zero property, zero product property, okay, which says that if these two things multiplied together give me 0, well, that means that one of them has to be 0. So either 2x plus 5 is 0 or x minus 2 is 0. And then if I solve these things, this means that 2x is equal to negative 5 or x equals 2. And then if I divide by 2, I get x is negative 5 over 2 or x is 2. So these are my possible solutions here. Okay, and then we just want to check that they work. Okay, so we can plug them into the original. So let's check x equals 2 first. So that's going to be 2 times 2 squared plus 2. We want to know, is that equal to 10? Well, 2 times 2 squared, that's 8, plus 2, it is equal to 10. So that is a solution. Okay, now what about x is negative 5 over 2? 2 times negative 5 over 2 squared plus negative 5 over 2. We want to know, is that equal to 10? So negative 5 over 2 squared, that's going to be 25 over 4. This is minus 5 over 2. The 2 can cancel with a 2 here, so I have 25 over 2 minus 5 over 2, and that's going to be 20 over 2, which is 10. So they're both solutions. So we have solution set contains both of them. So negative 5 over 2 and positive 2. Okay, so that would be the solution for this equation. Okay, now another way we can solve quadratic equations is to use the square root property. So if you have something squared equals a number, then your something should be plus or minus the square root of that number. So in example 4 here, we can solve this equation this way. Because we have x minus 1 all squared, let's start by solving for that so that we have our a squared on one side. So I'm going to divide both sides by 2 to get rid of that 2. So that gives me x minus 1 all squared equals to 9. Okay, now using the square root property, oops. We can take the square root of both sides here, okay, as long as we add the plus or minus. So that means that x minus 1 is equal to plus or minus the square root of 9, which is 3. And then we can add 1 to both sides to solve for x. So that means that x is equal to 1 plus or minus 3, which gives us x is 1 minus 3, which is negative 2, or x is 1 plus 3, which is 4. Okay, and then if you check both of them, okay, so if we check x equals minus 2, I have 2 times minus 2 minus 1 squared, and I want to know, is that equal to 18? So that's negative 3 in the brackets. When I square that, I get 9, and 2 times 9 is 18. So that one is a solution. What about x equals 4? So that's 2 times 4 minus 1 squared. So 4 minus 1 is 3. So again, this is 2 times 9, which is 18. So our solution set contains the numbers negative 2 and 4. And again, there's other ways to solve this equation, but you can use the square root property, which is probably the fastest way because of the form it's in initially. Okay, so you could have actually expanded everything out and then moved everything to one side and then factored. Regular factoring, you'll get the same answers. Okay, it's just a longer process. Okay, so I think there's one more to do here. So sometimes things are hard to factor, and then we want to use the quadratic formula. Okay, so that's given up here, so we can still see that. So if we wanted to solve this one on the right here, it's not in the right form at the moment. So I'm going to start by moving the 5x to the left-hand side by adding 5x. Okay, so that's going to give me 3x squared plus 5x plus 6 equals to 0. So if I was trying to factor this, I would want two numbers that multiply to give 3 times 6, so 18, and add to give 5. And no such numbers exist. So the factoring that way is not possible. So what we're going to do is use the quadratic formula. So if we use the quadratic formula, so now it's in the right form. So my A is 3, my B would be 5, and my C would be 6. So if I plug those in, so by the quadratic formula, x should be equal to negative 5, negative b, plus or minus the square root of 5 squared minus 4 times 3 times 6, all over 2 times 3. So that's negative 5 plus or minus the square root of 25 minus 4 times 3 times 6 is 72 over 6. So this is negative 5 plus or minus the square root of negative 47 all over 6. And now we see that there's a problem. Okay, so you cannot, a square root of a negative number does not exist. Okay, so that means that what we get here are not real numbers. Okay, so that means that this equation has no real solutions, or no solutions. Okay, so when you get a negative under that square root, which it talks about actually on the next page, so that this is, inside bit is the discriminant. Okay, so when it turns out to be a negative here, the square root of a negative never exists, so that's going to be when you get no solutions. Okay, one more example here. So the height of an object that's launched upwards is given by this equation. Okay, so S equals negative 4.9 t squared plus 20t. T is the time in seconds, and S is the vertical height in meters. So we want to know when the object is 15 meters high. So that means that we want the t value, or values, for which the S value is equal to 15. Okay, so that means we can just plug in 15 for S and then solve for t. So 4.9 t squared plus 20t. Okay, so let's move everything to the right-hand side. So I'm going to subtract 15 on both sides. That's going to make this a 0. So I have 0 equals negative 4.9 t squared plus 20t minus 15. Now this is a hard one to factor, so I'm going to use the quadratic formula. So let me just write here, quadratic formula, because now I'm in the right form. My A is negative 4.9, my B is 20, and my C is negative 15. So I plug all those in, I should have t equals negative 20 plus or minus square root of 20 squared minus 4 times negative 4.9 times negative 15 all over 2 times negative 4.9. Okay, so if you simplify that, in the square root, if you add all these together, you end up getting 106. Okay, and the denominator is negative 9.8. So that's going to give us two different values. So you're going to have t is negative 20 minus square root of 106 over negative 9.8, or negative 20 plus the square root of 106 over negative 9.8. So that means, maybe I should write t equals or t equals. So that means that t, it wanted 3 decimal places. So this first one is going to be 3.091. Okay, so that's one t value. Or t is going to be 0.990. Okay, so the height of the object is 15 meters after 0.990 seconds, and again after 3.091 seconds. Okay, so the idea, what's happening here, just if you're concerned why there's two answers, okay, so what's happening with this object, okay, when it's at time 0, so this is the time axis, and this is the height, the s-axis. So at time 0, the object has 0 height. Okay, and then you throw it, it goes up to some maximum height, and then it comes back down. Okay, so 15, the height is somewhere around here. Okay, so that means this first intersection, this is the 0.99, so around 1 second, and this second intersection, this is around the 3-second mark. So that's 3.091. So the maximum height must be somewhere between those, and it's bigger than 15. So those are a few examples solving quadratic equations in a variety of different ways.